Hi, a very good evening to all the students. My name is Effortlessly and today we'll be learning about circles. Okay. I really hope that I'll be able to clarify all your doubts if you get any. But if there are any doubts left over, you can always ask me in the end, and I'll make sure that I'll be clarifying them all. Okay. So let us head start to the circles. So what exactly is a circle? We'll be learning about it, the different terms associated in the circle like chord, segment, sector, arc. We'll also be learning about circumference of a circle, radius and diameter, tangents, and few theorems to be focused upon. Quickly, what exactly is a circle? A circle is the collection of all the points in a plane which are at a fixed distance from a fixed point in the plane. Okay. So for example, this is the center of the plane, a fixed point with the name point A. And you have your compass placed at a certain distance. This distance is the radii of the circle. At a certain equal radii or at a certain distant radii, you plot certain points around the point of focus, that is the center point of the circle. Joining all those dots will create a circle. That's it, simple. Okay. Moving on, you have two areas in the circle. Basically, one is the interior and the exterior, nothing but the inside area of the circle and the outside one. Okay. Coming to the third diagram, you can see there are two lines here, two line segments, basically PQ and AB. AB has its center O, which is also the center of the circle. Okay, this line AB is called the diameter of the circle. Clear? And the radii is nothing but half of diameter, that is OB. Okay, all the radii drawn inside the circle, like the OB here. If I draw one more line from the center of the circle to the circumference of the circle, I'll get back to that. Circumference will be at an equal distance. So OX at certain point, if I draw a line O and X here and OP, they both will be having the same length. Okay, just refer this diagram for easy understanding. I have the center of the circle and I am drawing all lines as many as possible to the circumference of the circle. Circumference is nothing but the length of the circle, basically. Okay, it's the length of a circle, okay, which is also represented by 2 pi r. We'll get back to the formula part later on. Okay, so AB is the diameter of the circle, OB is the radius of the circle, PQ here is called as the chord of the circle. It's a line segment, okay, drawn inside the circle, which has the two ends of the line segment over the circle or on the circumference of the circle. Clear? So this chord in the next diagram divides the circle into two parts. One is the major segment and the minor segment. Please note that arc, a terminology associated with the chapter circle, is very important. What exactly is an arc? An arc is a curve on the circle starting from an initial point of the line segment to the final point, that is Q. Okay, this is the major arc here and this is the minor arc. This major arc covers the major segment area and the minor one covers the minor segment. Okay, similarly we have another diagram which differentiates between the major and minor sector. We have a center point O. PO is one chord, OQ is the other chord. We have an arc, a larger arc above these two chords covering the major sector. Smaller one, minor sector, smaller arc. Simple? Okay, let's move on to the tangent. A tangent is a straight line. Okay, passing over the circumference of a circle. It is neither inside the circle nor outside the circle. Okay, and one more thing, if any line is inside the circle, any straight line passing through the circle is also called as the secant. Okay, what we are referring to is a tangent of circle. For example, PQ is the line, straight line passing through the circle, passing over the circle at a point A. Okay, clear? Also in the last diagram we have one more tangent drawn here and we have the radii. This is the point A. For example, just imagine this point A has been plotted here. So if I draw the radii connecting to the point A and if a tangent passes over it, whatever the angle that these two lines make is always perpendicular. Clear? Right. So quickly we'll move on to a couple of theorems on the circle. Theorem 1, equal chords of a circle subtend equal angles at the center. Okay, subtend in the sense they make or create or develop. There are many meanings of the word subtend, which means make or create or develop. Clear? Equal chords of a circle make equal angles at the center, right? So what we need to prove here, if you refer the diagram here, we need to prove that angle AOB and angle COD are equal. Okay, so what do we do now? We understand from the concept of radii that OD and OA are equal. Any radii drawn from the center of the circle, as many as radii you keep drawing, they will always have a same length. Okay, so OD and OA are equal, being the radii. Also OB and OC are also the radii of the circle, which means OA, OB, OD and OC, all these 4 lines are equal. Okay, so let us look at these lines from a triangular point of view. Okay, we have a triangle AOB and a triangle COD. Okay, OA and OB, OC and OD are equal, and lines AB and CD are equal too, because line AB and equals AD is already given in the theorem, equal chords. Okay, therefore triangle AOB and triangle COD from the triple S rule, that is side rule, are congruent, which means they are similar to each other. Okay, this gives that angle AOB is also equal to angle COD, corresponding parts of congruent angles. Okay, quickly moving to theorem 2. If the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. So we are just proving the converse of the theorem 1 in the theorem 2. Okay, now that we have to prove that these chords, that is AB and CD, are equal given these angles AOB and COD are equal. Okay, if the angle subtended by the chords of a circle at the center, subtended by the chords of a circle at the center, okay, then the chords are equal. We have to prove that AB and CD are equal. Okay, this theorem is the converse of theorem 1 in the figure. If angle AOB is equal to angle COD, which is already given in the theorem, these two triangles are congruent by the triple S rule that is explained earlier. Therefore, these two chords are of equal length, that is AB equals CD. So that's it for now. Probably I'll be looking forward for more. If you have any doubts, just let me know. Just let us work and understand together. I'll make sure that we always maintain a transparency in the learning, and I'll make sure that all of your doubts will be cleared as we follow through each concept. Okay, thank you, thanks a lot, have a great day, bye bye.